We often look at the moon and wonder, wow, what would it be like to live all the way up there? If your thoughts are filled with gumdrops and flowers, I'm sorry, but your bubble must be burst. This video will explore the question of how long it would take for an unprotected human to burn on the moon. To start off our journey to such a question, we must first explore the root source of where most of our light comes from, the sun. The sun is a gaseous giant filled with mainly hydrogen, helium, oxygen, and several other metals. But this is not what is important. It is the power that we want to find out about the sun. To figure out the full power of our sun, we can use the solar luminosity equation, which is a form of power emitted by photons measured in watts. The equation is represented by L circumpunct equals 4 pi k I circumpunct a squared. L circumpunct can be defined as radiant flux or radiant power, which measures the total power of electromagnetic radiation. This is equal to 4 pi multiplied by k, which simply shows that the value of one astronomical unit is not reflective of the mean distance between the Earth and the Sun. I circumpunct is the solar constant, which has been experimentally determined as 1367.7 watts per meter squared. And lastly, we multiply this by the square of the distance between the Earth and the Sun, 149,600,000,000 meters. To solve for a variable k, we simply take the exact mean value of the distance of the Earth from the Sun, 1 astronomical unit, or 149,597,871,000 meters, divided by the rounded value, 149,600,000,000 meters. This solves k to be roughly 0.998% of 1 astronomical unit. So when we plug in all our unknowns, we discover that the power of our sun is 3.839 times 10 to the 26 watts. Since we now know the power of our sun, we need to convert this value into an intensity felt by the moon. For this, we need to assume that the moon is wedged directly between the sun and Earth to avoid any complex angles. One equation we can use to assist us in this task is the absolute value of the intensity is equal to the power over the surface area, or 4 pi r squared. However, the r value in this is not the radius, but simply the distance between the moon and sun. We are missing one variable though, r. To figure out the distance of the moon from the sun, we need to subtract the known distance of the Earth and moon, 384 times 10 to the 6 meters, from the mean distance of the sun and the Earth, 1.496 times 10 to the 11. This comes out to be roughly 1.486 times 10 to the 11 meters. Now that all of our variables are solved for, we can figure out the intensity of light felt by the moon. This comes out to roughly 1,383.4 watts per meter squared. This intensity may seem extremely high at first, but we need to filter out which light will harm us from that which doesn't. Since we don't know the exact percent composition of light from the sun, let's assume that 60% of all light are harmful ultraviolet rays. Therefore, our intensity diminishes by 40%, becoming roughly 830 watts per meter squared. Before we move any further with the moon, let's look at Earth. On Earth, our atmosphere filters out roughly 97% of all harmful ultraviolet radiation from the sun. To find out the intensity on Earth, we need to use the known intensity from the sun on Earth, 1,367 watts per meter squared, and multiply it by 0.6 to get around 820 watts per meter squared. Then multiply that by 0.97 to get roughly 24.6 watts per meter squared, which is similar to that of a tanning bed. On Earth, with this UV light intensity, it can take roughly 20 minutes to start exhibiting symptoms of a burn. But what does this UV felt on Earth have to do with the UV felt on the moon? Well, our moon does not have an atmosphere like the Earth does, so UV light hitting the surface is undiminished. You experience all 830 watts per meter squared. In retrospect, this is 33.7 times greater than the UV on Earth. So if we convert our 20 minutes from a burn into seconds, we get roughly 1200 seconds for a burn on Earth. On the moon, the same burn would occur in 35 seconds. Although it would be too difficult to determine at what exact time you will be cooked to crisp, consider yourself stir-fry within 4 minutes of unprotected exposure to the UV light on the moon. But don't worry, you wouldn't have felt a thing. You would have gone unconscious within 15 seconds of being exposed to the vacuum of space.